All right, so in this video, we're going to talk about solving systems, and the method we're going to use today is to solve the system by using substitution. Now, all the methods that you can use, you get to pick which one that you like the best or which one you think is going to work for that problem. This video is talking about just substitution. So, a couple of steps. Usually what happens is, with a system, you have equation number 1 and then equation number 2. They can be written in any format. We just need 2 equations with that lovely squiggle bracket there. So there are kind of 5 basic steps to go through with this substitution. Step number 1 is you're going to pick one equation and solve one equation for a variable. Trying to write shorthanded here. So you solve for one variable, either one doesn't matter. Then step 2, you're going to substitute what you got into the other equation. So if you solved equation 1 for a variable, you have to substitute into equation number 2 and vice versa. Step 3, once you have that substituted, there's only going to be one variable present and you need to solve for that variable. Step number 4 then, now we know what one of the variables equals. It's going to equal a number, maybe 10, and you're going to substitute that value into original equation. It doesn't matter which one, just pick one. And then once you substitute that, you'll once again only have one variable and you'll solve for that variable. And then you'll have 2 numbers and your answer will be written as a coordinate, x, comma, y. So solve for a variable, substitute, solve, just going back and forth on this. So let's try a couple examples. All right, so here are the 2 equations. And remember, a first step for substitution is we're going to pick one of these equations and solve for a variable. It does not matter which one you pick. We can pick the first equation and solve for x. Or we can solve for y. Or we can pick the second equation and solve for either variable. It doesn't matter. So what I'm going to do, I'm going to decide to pick that second equation and I'm going to solve for x because I can. So all we're going to do is solve for that. And I know that I can move that 7y to the other side. So the equation looks like this. And then I know I can divide by 2 so that x is by itself. All right, now that we have this equation, I know x equals that, what I have boxed. And what we're going to do now is substitute what I just boxed into the other equation in for that same variable. So we're actually going to substitute that right there. I am going to erase part of this just so I can save room. Ideally, you would just make sure you move down a line or off to the side. That way you have enough room. So everything about that first equation stays the same. If you noticed, I did not write x this time. Instead, I put parentheses and left a big space because we were actually going to substitute what we just solved for right here. All right. Now that's what has been substituted in for x. If we look at this equation now, the only variable left is y. So now we're going to use our handy dandy math skills and just solve for this. So what we get to do is first I'm going to distribute that -5. So we're left with -35 divided by 2y plus 85 divided by 2. And the rest of the equation stays the same. Now at this step, we have fractions. I don't like fractions. I'm going to try my darndest to get rid of everything. So I notice that all my fractions have this common denominator of 2. Now I can't combine them at all, but what I can do is look at both sides of the equation and multiply it by whatever that denominator is. What happens then is we basically distribute that 2 on the left-hand side of the equal sign, and it basically gets rid of our denominators. And does multiply everything else. So we might have to deal with bigger numbers, but now we don't have any fractions, which is nice. Now all we have to do is combine our like terms and solve for y. Combining our y's, we get -51, and subtracting the 81 to the other side gives us -51 as well. So I know y has to be 1. So right now, my answer, I know that the y value is going to be 1. We can kind of write that off to the side, that way we don't forget later. All right, now that we solve for one of our variables, it's going to be pretty easy to solve for the other one. So we just get to pick one of the original equations. I'm going to go ahead and pick the first one. And because we know, we just found that y has to be 1, we're going to substitute that value into that first equation. And if we notice, now we only have the variable x. Now we can solve for it just like we've been doing forever. And so we find out that x equals -5. So we're going to put that right in our answer, and there you go. To double check it, you always want to check this, and you can just type it in your calculator if you want. Substitute your answer into both equations. -5 for x and 1 for y, and see if this equation is true. That gives us a +25 minus 8, and we know that does equal 17. So check mark, that is correct. And you also want to have to do that with the second equation as well. Sometimes we make mistakes and our answer will work for one of the equations, but not the other. So let's go ahead and check that really quick. So we know that'll be -10 minus 7. Does that actually equal -17? Which it does. So another check mark there. -5, 1 is our answer. Okay, now an example 2. This is a very, very special example, and we'll see why here in a second. So here's our two equations. And what we're going to do, use substitution as well. So I've looked at this and I've determined that I want to use the second equation again. And I'm going to solve for x. And remember, you can pick either equation and either variable. It doesn't matter. So I'm going to go ahead and solve for x. I'm going to move that 3y to the right-hand side. And then divide by 3. You can kind of see why I picked the second equation now. All my coefficients are integers. I don't have any fractions or decimals. So now what we get to do, I'm going to take this and substitute it into that same variable, into the other equation. And now all we have to do is solve. So we are going to distribute this 9. And then I notice that my y's here are like terms, so we can add those together. And that actually makes it 0y. Now, the 0y does not have to be there because 0 times anything is 0. So, actually, we get this answer. And we're smart. We know that is not a thing. We know that negative 27 does not equal negative 12. So what does that mean here? That actually means our answer is no solution. Ran out of room. But that is our answer. When we get a final, when we're substituting, when we're doing anything, and all the variables disappear, and all we have left is our numbers, if they do not equal each other, your answer is no solution, and you don't have to solve for anything else. We are done with this problem.